Hello, developers. You know, it's crazy how one little comma can completely break your entire API response. Let me show you what I mean. Watch this parse fail spectacularly just because of an extra comma. Now, when I delete that one character, boom, it works perfectly. Let me explain what just happened there. That trailing comma after the last property is actually invalid JSON syntax, even though JavaScript would normally allow it. The parser throws a specific error because JSON requires clean, predictable structure without any ambiguous formatting. JSON seems friendly at first glance, but it's actually got some really strict rules you need to know. Stick with me through this video, and you'll walk away with a senior-level JSON toolkit that most developers take years to figure out. Let's understand what JSON is and why it matters. Here's the core idea. JSON is just text, while JavaScript objects are actual runtime structures in memory. When we need to send data over the network or store it somewhere, we convert our objects into text using JSON. Then when we receive that data, we convert the text back into objects. Looking at this code example, you can see we're taking a live JavaScript object with methods and complex types, then using json.stringify to create a pure text representation. Notice how the methods disappear and dates become simple strings. That's because only cares about the data, not the behavior. That cycle, object to text, text back to object, is the heartbeat of pretty much every API you'll ever work with. Now let's look at the basic building blocks. JSON really only understands 6 basic shapes: strings, numbers, booleans, null, objects, and arrays. Let me show you a simple object that uses the core primitives. We've got text values, numbers, true, false booleans, and null for empty values. In this code example, notice how every key is wrapped in double quotes, and string values get the same treatment. The numbers and booleans stand alone without quotes, which tells the parser they're literal values, not text. That null value represents intentional emptiness, different from undefined, which JSON doesn't support. Now there are 2 rules I want you to burn into your memory. Keys always use double quotes, and strings always use double quotes. No single quotes for keys, no single quotes for strings. That's an instant failure in JSON land. Let's talk about arrays and nested structures. This is where JSON gets really practical for real-world applications. APIs absolutely love arrays of objects. Think about a list of users, a list of products, that kind of thing. Each item in the array is a plain object, and inside those objects you'll often find more arrays for things like tags or skills. Looking at this user data example, you can see we have an array wrapped in square brackets, containing multiple user objects in curly braces. Each user has a hobbies array inside them. That's nested data structures in action. The consistent property names across users make this data predictable and easy to process. The mental model here is like a tidy spreadsheet. You've got rows of data, each row is an object, and some columns might actually contain lists themselves. One pro tip: keep your property names consistent across items, because the code that uses this data will depend on that consistency. Let's cover the strict rules and common mistakes. Now, JSON is intentionally unforgiving by design. No trailing commas allowed, no comments for documentation, no undefined values, no NaN, no infinity. And remember, double quotes only, no exceptions. Let me walk through these examples of invalid JSON. See how this first one uses single quotes? The parser immediately rejects it because JSON demands double quotes everywhere. This next one has a trailing comma after the last property. That little character breaks everything. And here's one trying to include a JavaScript-style comment. JSON has no concept of comments, so it fails. If you're coming from JavaScript, these rules might feel a bit harsh at first, but that's actually the point. This strictness is what makes JSON predictable and reliable across every programming language. Let's dive into Parse and stringify. These 2 functions are the workhorses of JSON. Parse turns text into live data that your code can work with, while stringify does the opposite. It turns your data back into text for storage or transmission. Looking at this parse example, we're taking a JSON string and converting it into a real JavaScript object. Suddenly, we can access properties like user.name and call methods on the resulting object. With stringify, watch how we take a complex object with nested data and flatten it into a clean text representation. When you're using stringify, you can add spacing to pretty print your JSON, which is super helpful for debugging or version control. One gotcha to watch out for: circular references. If an object points to itself, stringify will fail because it can't handle that infinite loop. For debugging, you might want to use a safe stringify that replaces circular references with a simple label. All right, we've covered how to make JSON readable and safe. Next, we're going to make it private and smart with some advanced techniques. We've built a solid foundation with the basics, but the real power comes from these next advanced features that handle security and data transformation automatically. If this has already saved you some headaches, hit that subscribe button. This channel is all about keeping your UI clean and your data handling sane. Let's explore advanced replacer and reviver functions. Here's where JSON gets really powerful. Before you send or log data, you can use the replacer to automatically scrub out sensitive information like passwords or API tokens while still exporting everything else. Look at this replacer example. We're passing a function as the second parameter to stringify that checks each key. When it encounters a password key, it returns undefined, which tells stringify to completely omit that property from the output. All other data flows through untouched. On the flip side, when you're parsing incoming data, the reviver can upgrade plain text back into rich types. A classic example is date strings. You can spot the ISO date format and automatically convert it into a real date object during parsing. Suddenly, all your date comparisons and formatting just work without any extra code. Let's see how JSON works with real APIs. In the real world, network calls give you raw text responses. Most modern HTTP helpers will handle the JSON parsing for you automatically, but you should always check the response status first. Looking at this fetch example, notice how we await the response, then check if it's okay before calling response.json. That .json method is doing the json.parse for us behind the scenes. The try-catch wrapper ensures we handle network errors gracefully without crashing our application. Make sure you handle non-200 responses gracefully and only then start working with the parsed data. Let's do a quick mental checklist. Double quotes for keys and strings, no exceptions. No trailing commas, no comments. The allowed types are strings, numbers, booleans, null, objects, and arrays. Looking back at our examples, remember how each valid JSON snippet followed these exact rules. The invalid ones always broke one of these fundamental requirements. This consistency is what makes JSON work across every programming language and platform. Use Parse to convert text to data, stringify to convert data to text. The replacer helps you hide sensitive information, while the reviver can restore complex types like dates. This is the foundation you need for working with JSON like a pro. Quick quiz before we wrap up. I'm going to show you 3 code snippets and only one of them is valid JSON. Which one do you think will pass the parser? Pause and think. Looking at these examples, option A has single quotes, option B has a trailing comma, and option C follows all the rules we've covered. The parser will only accept option C because it uses double quotes consistently and has proper syntax throughout. The answer is the one without trailing commas and without single quotes. I'm curious, tell me in the comments which JSON rule tripped you up most recently. Thanks for watching, and I'll see you in the next one.